Okay, now we're going to talk about the vertical line test. So the vertical line test answers the question, when is a graph the graph of a function? In other words, if I just draw two coordinate axes like this, so you have your inputs here and your outputs here, and I draw some crazy picture, when does that picture correspond to the graph of an actual function? And so to answer that question, we have to think about what the essential properties of a function are. And there's really only one essential property. Each input must have only one output. In other words, if we move anywhere along the x-axis, along our inputs, then above that point, or below that point, you should only be able to find one thing, which corresponds to the output, the single output of the function. If you found more than one thing, that would mean that your function, well, the function that your graph would represent, would have to have two outputs, which is not allowed. And so the vertical line test gives you an easy way to test whether a graph ever has two outputs for a single input. So here, for example, we draw a vertical line, and any vertical line we draw should hit only one point on the graph. So here we see we drew the vertical line, it hit this point, it didn't hit any other points, which is good. And no matter where we draw a vertical line, we will only ever hit a single point. So this graph passes the vertical line test. Now let's move to this graph over here. If we draw a vertical line like this, here's our input. But as we see, the vertical line hits two separate points. What this means is that this graph cannot represent a function, because if it did, the function would have an input, namely this point right here, which corresponds to two different outputs. These 2 points where our vertical line passes. So this graph does not pass the vertical line test and is not the graph of a function. So to recap, the vertical line test says a graph is the graph of a function exactly when you can draw vertical lines anywhere on the graph and they will only hit one point. So here's another graph, and we see that no matter where you draw a vertical line, it intersects the graph in only one point. So this also passes the vertical line test and represents the graph of a function. For our last example, we'll look at a circle. And see, for a circle, if you draw a line right here, it passes through two separate points, which means that this does not pass the vertical line test. And so this is not the graph of a function. In other words, there's no function whose graph is a circle.